Okay, guys, very quickly, I'm going to learn something beautiful in this class. And I've shouted it over and again that understanding is cardinal. So we're going to be looking at everything about your ionization energy from the beginning to the end. Don't cram, understand. If you know these things, you blast any exam. This is our lesson number 4. What is ionization energy, right? Very important. But before we go into definition, I'd like you to understand this very quickly.
Hold on a bit. The complete series of classes, right, as far as your syllabus is concerned regarding your Jamb and WAEC, everything has been covered in details for you in the LearnLift app. And guess what? The sweet part is that you have access to your CBT, right? You have access to your video lessons, you have access to your notes, you have access to your past questions. Everything from the beginning to the end is directly in the LearnLift app for you. So all you have to do is just mark down to Play Store or App Store and download the LearnLift app where you follow all your classes from the beginning to the end. A quick one before we move. Let's get back to class. Enjoy.
Let's say this is an atom. I'd like you never to forget this. The electrons in an atom, they are held toward the nucleus by electrostatic force of attraction. You know, in an atom, there are two major forces that are in operations there. Number one is called the nuclear force. And nuclear force is a type of electrostatic force of attraction, right? Okay, what is nuclear force? First. Nuclear force is that force that is coming from the nucleus. Which part of the nucleus? The protons in particular, right? And they are now dragging electrons to themselves. So that protons that are positively charged, dragging electrons that are negatively charged to themselves, that is an attraction force. That force of attraction is called the nuclear force of what? Attraction. The one you call your electrostatic force of attraction. The second electrostatic force we have, right, is what we call your shielding or your screening effects, where the outer electrons and the inner electrons, they have repulsion that is occurring between the two of them. That's your shielding or your screening effects, right? So we can also call that shielding or screening effect electrostatic force of what? Repulsion. So, but now I want you to understand that electrons in an atom, right, they are held to the nucleus. We are dealing with one of the electrostatic force, and that's the electrostatic force of your what? Attraction, the one you call your nuclear force, right? Beautiful. Between the nucleus and the electrons. But very importantly, you must know this, however, that when an atom absorbs sufficient energy, so it's possible that we channel energy towards an atom, right? What happened? An electron can be completely removed. What do we mean by this? Let's say this is our atom, right? It absorbs sufficient energy, right? That energy can go in the form of your packets of energy or your quanta. What happened? Because the energy is sufficient enough to knock off the electron. So you see, electron is now what's ejected. So when an atom absorbs sufficient energy, what happened? Electron can be completely removed. And that is what has happened here very quickly. So understanding and having this in your mind, right? The question now is, what is ionization energy? Understand this simple. Ionization energy is the amount of energy required to remove the outermost electron from a neutral atom or ion in its gaseous state, thereby converting it to forming a positively charged what? Ion. This is called your ionization energy. Very simple. You are going to learn its definition with me. We'll just say it 2 times and then it must enter into you. What is ionization energy? It is the amount of energy that is required, right, to remove the outermost electron. We are knocking off the outermost what? Electron, right, from a positive, from a neutral atom or ion in its gaseous state, but it must form what? A positively charged ion. For the last time, what is ionization energy? It is the amount of energy that is required to remove the outermost electron from a neutral atom or ion in its gaseous state. But what will be formed? A positively charged ion is going to be formed. Sir Peter, look at a powerful question that was asked by Jamb 1990 question 11. They asked this sweet question. The question says, let's go. They gave you X, right, in the gaseous state. right, is being converted into your X positive plus your electron minus. What do we say ionization energy is? We say that it is the energy that is required, right, to remove an electron, that is your E minus electron, right, from a neutral atom or an ion in the gaseous state. And what do we convert it into? We are converting it into a positively charged ion, your X positive. The type of energy that is involved in the above transformation, what is it? Option A say ionization energy. Option B say sublimation energy. Option C say lattice energy. And then option D say electron affinity. What is the answer? Ionization energy. Option what A is the answer? We said that ionization energy, don't forget, right? It is the energy that is required to remove an electron from a neutral atom, X, right? Beautiful. So it is now acquiring or absorbing energy. So you are pulling in your what here now? Energy, right? So that an electron can be removed from it. What is being removed from it? An electron is removed. But because electron is removed, the neutral atom is now converted into a positively what? Charged gaseous what? Ion. At the end of the day, that's all you have. So for the last time, what is ionization energy? It is the energy required, or you may even say it is the minimum amount of energy required, right, to convert an atom or an ion into a positively charged what? Gaseous ion. But the atom you are going to be converting, you are converting it from the neutral state into what? A positively charged what? Gaseous ion. So that energy that accompany it is called your what? Ionization energy. Does it make sense? Are you sure?
So when it comes to creating an account, right, this is the interface of the app that you can see. You can see create account, and you can also see login. Now, what you do is this: as a new user, you don't have an account yet, so you don't need to go and log in. You go and create an account as a new user. Click on that create account button. Once you click on it, the next thing is put your phone number. Place in your phone number. You can see +234, then put your phone number, whatever your phone number is. If you don't have phone, you can use your mommy's phone number and put it there, right? Or your daddy's phone number. Use it, and then you can proceed and create the account. So let's go. So once you create the account, you have put in your phone number. What happened? Put your name, your correct phone number, please. Put your name. If your name is John, what do you fill in there? John. And then your last name, Frank. Fill in John Frank. And what's your email address? Okay, if your email address is johnfrank3@gmail.com, you fill it there. And then your password, very important. You create your own password, 6 digits. You can use your phone number, the first 6 digits of your phone number, or the last 6 digits of your phone number. Or you can, okay, since your name is John Frank, you can say, okay, my password name is John, right? John 123. And then you go and repeat the same thing, confirm password. What will you type there? Your John what? 123. You can decide to view it to yes or, and then see whether you are doing the same thing, whether what you are doing is correct, right? All you have to do is just click the I button there, and then you view it. And then come to select education. You are preparing for Jamb or WAEC. In select education, there are 4 plans there. University, that's for people that are in university. Probably 100 level, 200 level, right? Yes, their classes are also there. Secondary, for those in secondary school, primary. But for Jamb and WAEC, click WAEC Jamb Pursue TME, right? As the select education. Select level. You are not preparing for Pursue TME, you are preparing for Jamb and WAEC, right? Okay, click on the what? Jamb and what? WAEC. And then create your account. 2 seconds. Plus, you don't enter. It will load, and then it will open for you. And it will tell you, welcome, John, right? Your classes are now what? Ready. What do? Start learning.
You get this very quickly with me. I'd like you not to forget this. Again, what is ionization energy for the last time? It is the amount of energy, or the minimum amount of energy that is required to remove the outermost electron, right, from a neutral atom or an ion in the gaseous state, but what will be formed? A positively charged ion is going to be what's formed. For the last time, write the equation for me that depicts ionization energy. What is it? It is your X like this, right? Gas. What is it going to give us? Of course, energy is going to be accompanying this, right? What is it going to give us? Your X positive, and this is your gas, plus your what? Electron that is going to be what? Removed from it. If you get this very quickly with me, I'd like you not to forget this, that ionization energy is a measure of how strongly an atom holds onto its electrons. It's just like, for example, when you see your domestic fowl, when they give birth, what happens? The mother hen, right, try to protect the eggs, or even if the eggs have been hatched into chick, what happened? The mother hen try to protect all those chick. You cannot just come and carry anyone easily, right? So the measure of how strongly that mother hen is holding onto the eggs or the chicks is more like ionization energy, right? Okay, what is ionization energy now in chemistry term? It is a measure of how strongly an atom holds onto its what? Electrons. You know, there are some of us, some of you that you are listening to me now, that you are so useful to your parents, right? That anytime you are away from them, they feel somehow they miss you. But there are some of you that your mommy is just praying so that you just gain admission and carry your wala and just go. Hey, ta. That means they are not holding you strongly. They are holding you how? Weakly. Right? That means your own ionization energy is poor. If they are just praying so that you can just gain admission and just live with your wala, your ionization energy is very, very low. So what is ionization energy? It is the measure of how strongly an atom holds onto its electrons. So the atom cherishes the electron. They don't want to lose, so they are holding it tight. Does it make sense? If you get this very quickly with me, I'd like you not to forget this. There's what we call your first ionization energy, your second ionization energy, and your third ionization energy. What's the difference between the three of them? You keep hearing it: first, second, third ionization energy, and they are asking Jamb and WAEC questions from here very quickly. First, which one is your first ionization energy? Very simple. Look at it very quickly. What's the definition? Tell us that first ionization energy is the energy required to remove the first electron. You see, that first electron you are removing must be outermost electron, right, from a neutral atom. So the energy required to remove the first electron, not second, you are removing the first electron from a neutral atom. What is that energy called? It is called your first ionization energy. Sir Peter, talk to me. Look at this very quickly. Aluminium is number 13, right, in the periodic table. That means it has 13 electrons, 13 protons. So the energy that we require to remove the first electron from aluminium, we are now converting it from Al, right, into Al plus. That first energy is called your what? Your first ionization energy. Simple, that's it. So what is first ionization energy? It is the energy that is required to remove the first or the outermost electron, the first outermost electron we're here, from a neutral atom. What is it called? First ionization what? Energy. Does it make sense? Perfect. If you get this very quickly, what is the trend for first ionization energy? We'll look at the trend across the period. We'll look at the trend down the group. How does it vary? I'd like you not to forget this, that it decreases down a group. Now listen carefully. Your first ionization energy, as you are coming down the group, what will happen to it? It will decrease. So it decreases how? Down the group. Why is it that first ionization energy will decrease down the group? First, all these two things. We said that first ionization energy does what? Decreases down the group. Across the period, what will happen? It will increase across a period. So it increases, right, across the period, and it decreases down the group. Why is it that first ionization energy will decrease down the group? I like not to forget this, that as you are coming down the group, right? Beautiful. Maybe your period 1, your period 2, your period 3, your period 4, your period 3, your period 3, your period 4, etc. and so on and so forth. What happened there? Down the group, you can see that the number of the shells is increasing. And because the number of shell is increasing down the group, first thing, the atom will be becoming larger, right? So down the group, atoms, they get what? Larger. Number of shell is increasing, automatically atom will get larger. As they get larger, the valence electrons are now farther away from the nucleus. And because they are farther away from the nucleus, as you keep coming down the group, what happens? It's very simple. You now need lesser energy to remove the valence electron. But in your group 1, you need stronger energy to remove the valence electron. In your period 1, you need stronger energy, right? Beautiful. To remove electron. So as you are coming down, don't forget that you are coming down the group, right? Beautiful. Like this guy now, argon and helium, which one we need stronger energy to remove the valence electron? Of course, you need stronger energy for your helium compared to your argon. Why? Because the size of your argon is larger than that of your helium. So the valence electron in your helium, they are held strongly because the size is small. So the force from the nucleus is high, is dragging it to itself. Compared to your argon, the size is big. So the valence electrons are loosely held, right? Beautiful. So to remove the valence electron will now be what? Much more easier. So don't forget that your first ionization energy does what? It decreases down the group. Don't forget that. Now, what about across the periods? What will happen there? Across the period, what happens is that first ionization energy increases. Now, you know, as you are going across the period, what happens? Number of your protons increases. As number of protons are increasing across the period, for example, this guy has 3 protons, this guy has 4, this guy has 5, this guy has 6, this guy has 7, this guy has 8, this guy has 9, right? Number of proton is increasing. As number of proton increases, what happens? Nuclear charge will increase. So you have greater nuclear charge across the period. And because nuclear charge is increasing, stronger force from the nucleus will be holding the electrons closer to itself. What is the trend for first ionization energy? Don't forget, it decreases down the group and then increases how? Across the period. Does it make sense? If you get this very quickly with me, what is now your second ionization energy? Very simple. When we talk in terms of second ionization energy, I like not to forget this. What's the definition? It's very simple. It is the energy that is required to remove a second electron. You are not first has been removed, right? Now you want to remove a second electron from a singly charged ion. So that ion must have one charge first. You want to now remove another electron from it. That is called your second ionization energy. Now look at this very, very quickly. This guy is not just Al as aluminum, it is Al plus, aluminum plus. It has lost one electron already. Now you want to now remove the second electron from it. That energy that you need to come and remove that second electron from a singly charged electron is called your second what? Ionization energy. So this energy that you need here, what is it called? It is called second what? Ionization what? Energy. Does it make sense? Are you sure? Beautiful. Now, first and foremost, catch the logic here. In your Al aluminum, right? How many protons do we have here? Protons is equal to 13. Electron here is how many? 13, right? Beautiful. But in your Al plus, tell me what happened here. How many protons do you have here? It is still 13, but electron, it has lost one electron. How many electrons do we now have here? Beautiful. Electron now is now 12 here, right? Beautiful. If you now come down to your Al2 plus, that will be formed at the end of the day in your second ionization energy. What happened there? How many protons do we have there? 13. But how many electrons do we have there? It has lost 2 out of 13, right? Now left it 11 electrons. Only you reason it. If 13 protons in this guy here, for example, this guy here, 13 protons is to drag 13 electrons to itself. Can 13 protons drag 13 electrons? Yes, it will drag it. But you observe that if 13 protons is now to drag 12 electrons, it will even drag it and the size will be smaller. Perfect, right? Beautiful. So if the size is now smaller in Al plus, for you to now come and remove an electron, for Al plus to lose an electron, man, it will be difficult for Al plus to lose electron compared to Al. But what about your Al2 plus? It is now even worse because electron there is now 11. So what happened? The size of that one will even decrease further. Why? Because the 13 protons will drag the 11 electrons well to itself. So for Al2 plus to lose an electron, you need greater energy for Al2 plus to lose one of its electron at all. Right? Now, the question that I'm going to ask you is this: what is the trend of your second ionization energy? You must not forget this. The second ionization energy will always be greater than your first ionization energy. Why? Because the remaining electrons that you have, right, 11 electrons that you have there, they are held more tightly by the 13 positively charged protons. They are held tightly. So you need greater energy for them to even lose out any electron. Does it make sense? So as a result of this, I like you not to forget this. The second ionization energy is greater. You can see that there is greater than symbol there, right? Beautiful. Second ionization energy is greater than your first ionization energy. This is the first thing you must hold here very quickly. Beautiful. If you get this very quickly, man, you are very, very sure. The next one is your third ionization energy. What is third? Already in your mind, you should be picturing how third ionization energy should look like. What is it? The definition is very simple. Tell us that third ionization energy is the energy that is required or needed to remove a third electron from a doubly charged ion. So already, let's say, for example, we have our Al2 plus, right? This gas already lose how many electrons? 2. What is the energy that is required for you to lose another electron addition to make it the third? That energy is called your what? Your third what? Ionization what? Energy. Very simple. Now, the quick question is, your third ionization energy, first and foremost, listen and understand this. In your Al2 plus, how many protons do we have? 13. How many electrons do we have? 11. Now, when you now move it further to Al3 plus, how many protons do we have here? 13. Electron here will now be 10 because it has lost 3 electrons. Because electrons are even smaller, that means the 13 protons can drag those 10 electrons closer to itself to even make it further smaller in size. In other words, we can say that the trend for your third ionization energy is such that third ionization energy is higher or greater than your second what? Ionization energy. Yes. Why? Because the positive charges, they have increased. In other words, it's not that the positive charge actually increased, but it is the function of the positive charge that has highly increased there. Why? In your Al2 plus, we said that electrons here are how many? 11. Proton here is how many? 13. But in your Al3 plus, how many protons do we have? 13. But electron is how many there? 10. Right? Beautiful. So these 13 protons can drag that 10 electron further closer to itself. Right? Making it increasingly difficult for you to be able to remove an additional what? Electron. It will be so difficult for you to remove any electron from your what? Your Al3 plus. That's why third ionization energy is greater than your second ionization energy. Does it make sense? So you must not forget this very quickly. If they ask you every day, tell us that third ionization energy is what? Greater than your second what? Ionization energy. If you get it very quickly and you are very, very sure, I'd like you to note 2 things very quickly. Your first, your second, your third ionization energy. Which one is greater? You already know that your third ionization energy, third, is greater than second, which is greater than first. In other words, which one is the least? The least is the first. So we can say your first ionization energy is less than your second ionization energy, less than your third ionization. These two, any one is what they will ask you in the exam. So your third ionization energy is greater than second, greater than first, or your first ionization energy is less than second, less than third. Amaka, Idu, does it make sense? I will do. Sure, you understand this now. Beautiful. If you are very, very sure and you know deep down inside you that you understand this to the core, that means you can flow and we can go together.
Now that you have created your account, right, for you to start learning, what do you do? Okay, you can see that your use of English is there, mathematics is there, biology is there, physics is there, chemistry is there. Your classes are organized, they're all there for you, right? What do you do? Okay, I want to start learning biology. So click on the biology, immediately you click on it, living organisms, that's chapter 1, right? Oh yes, that's strictly to your Jamb syllabus. And what happened? Let's say, for example, you want to watch your class on cell and probably cell structure, right? What happens is that you click on it. Immediately you click on it, you see all the classes will display history of cell, types of cells, cell organelles, and all of that. Okay, sir, I want to watch history of cells. You click on the history of cell immediately. Your class will start playing for you. It's easy and it will start playing for you easy and direct. And what happened? You can even choose to make it full screen, right? Make it full screen. What happens? You are started learning and you are enjoying your classes. In fact, you may choose to say, okay, I want to download my classes. In fact, you can fast forward, you can take it backwards, you can pause, you can rewind, anyone you want to do. You can even say, oh, sir, I want to download my classes, right? Probably you use Nightsub just to click on download buttons. When you click on download button, you see the download. Before you know what will happen, the download will start loading. As it start loading, you can see it is moving. And then it's enter your phone. Are you getting it now? You can now go and start watching your downloaded classes. You can download as many classes as possible as you want to download. Now, you can even choose to say, okay, sir, that's the notes underneath it. It's the same thing for everything. I want to download my notes. All you have to do is click on the download for your notes. Before you know what is happening, it has entered your phone. You may choose to come to the notes, right? Under the characteristics of living things, let me open the notes and read the notes and go through the past questions. So you see, well organized and structured notes, direct to the points, focusing on your syllabus for you. There are past questions for you in abundance. You see, you have your past questions here. You can choose to say, okay, I want to zoom it in, right? And then the same thing for all subjects. And you are following. The answers are there. Number 1 answer is B. Why is the answer B? It is explained for you in details. Every singular thing. And then you are following your classes. You are done with that. You come to the next. You see your notes. Everything structured and organized to the core. In fact, at the end of the day, there is a blow kiss for you. You have done well. Get out. You too much. Everything is structured and organized for you in the app. Right? And you can now choose to say, okay, sir, what about chemistry classes or physics classes? You can do same. Use of English, all of them, they are there. When you click on your chemistry classes, what happens? Separation of mixtures and purification. All of them are in line with your Jamb syllabus. Chemical combination, right? It just goes straight. You see, chapter 1 alone has 39 videos. 39, you sit yourself down, and you start learning. And you are following all of them one after the order. Does it make sense? Are you with me? When you want to access your download classes, all you have to do is just scroll down, right, on your home interface. Go to your access your download classes. Start now. You start. You see them, right? In fact, you may even choose to go and practice CBT, right, or past question. Let's say, for example, I go to my CBT, the one that has to do with my my biology. Then I want to take all the questions on that cell, probably your WAEC cell or the Jamb question on it, right? Just to click on it. So you see, all the questions are there. There are 40 questions there for you already. All of them on that cell. What happened? Which of the following cell inclusion can destroy other cell organelles? Probably you now say, oh, some answer is lysosome. You choose it, you go to next like that. At the end of the day, you see your answer, see your corrections. All of these things are in the LearnLift app directly for you. Are you with me? So as far as your Jamb 2025 is concerned, my dear, you don't have an excuse whatsoever to have anything less than 300. Are you with me? All your classes are available for you. All you have to do, start learning now.
Download the LearnLift app now.
Get that very fast, please. I'd like you not to forget that ionization energy, how do we measure it? We measure it using a gas discharge tube experiment. That's what we use, right? Once they usually ask this question, what do we use to measure ionization energy? Your gas discharge tube is what we use to measure what? Ionization energy. You get that very fast. What are the factors that determine ionization energy? Let's rock it together. There are a lot of questions here. when we are done, by the time we are looking at all the questions, if you fail anyone, you will hear them from our hand. There are 3 major factors that determine ionization energy. How many are there? 3 of them. So list the 3 for us. They include the following. Number 1 is called atomic size. What's number 1? Atomic size. And screening effect by inner electrons. So atomic size and screening effect by inner electron is one of the major factors that affect ionization energy. Number 2 is called nuclear charge. And then number 3 is called electron configuration of the atom. Give me the 3 factors that affect ionization energy. Atomic size and screening effect by inner electrons, right? That screening effect is also called your shielding effect. So atomic size and screening effect or shielding effect by the inner electrons. Number 2 is called the nuclear charge. And number 3 is called the electron configuration of the atom. Let's look at them one after the other. The first is atomic size and your screening effect by your inner electron. How does it affect ionization energy? Right? Don't forget this. That please, if we are considering your alkali metals, which are the group 1 metals, what's their variation down the group? Let's say, for example, we have these guys here, right? You know, your group 1 elements are called the what? Alkali metals, right? Beautiful. And under there, let's start with your lithium, your sodium, your what? Your potassium. As you are coming down the group, what happened there? First thing you must know is this. We said that first ionization energy, it does what? It decreases down the group and increases across the period. We established that for first ionization energy, right? Why will first ionization energy decrease down the group? It's very simple. Why? The reason is because as you are coming down the group, right, you know, lithium, your sodium, potassium, number of shell is now increasing. As the number of shell is now increasing, there is now greater distance between the electrons and the nucleus. So there is greater distance, right, from the electrons to the what? The nucleus. What happened? And because of that greater distance, it will create a weaker force of attraction from the nucleus acting on the valence electron. And because the force there is now weaker, you need less energy, right, to remove the electrons that are now in the valence shell. Are you getting it now? Don't forget that atomic size has effects on your ionization what? Energy. Beautiful. And you know that your screening or shielding effects, right? It is that effect or the force that's now occurring between the outermost electrons and the inner electrons, right? Thereby they are now trying to push the outermost electron away from the what? From the innermost electron, thereby increasing the size of the atom. So atomic size as well as your shielding or your screening effect, they have effects on your what? Ionization what? Energy. Does it make sense? Beautiful. You get that very quickly with me. Number 2 is nuclear charge. Oh yes, your nuclear charge has effect. Don't forget that the nuclear charge, like for example, your lithium has 3 protons, right? Beautiful. This guy has 4, this guy has 5, this guy has 6, this guy has 7, this guy has 8, this guy has 9, this guy here has how many? 10. I like you to understand this very quickly, right? That when we consider elements in your second period, that's period 2, from your lithium to your neon, hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon. So if you're looking at your lithium to your neon, what happened there very quickly? There is a general increase. There must be increase in your first ionization energy because we said ionization energy increases across the period. Why? It is so because the nuclear charge, which is a product of the number of protons, is increasing across the what? The period. Does it make sense? Beautiful. If you get that very quickly, again, I'd like you not to forget this very quickly, that across the period, what happened? Nuclear charge does what? Increases. Across the period, atomic size will decrease, nuclear charge will increase, atomic size will decrease across the period. Don't forget that this stronger, because there is that increase in nuclear charge, it will result to a stronger attraction between the nucleus and the outermost electron. And because there is stronger force there, you require more energy to come and remove a valence electron from it. Are you getting it now? It's just like, for example, a lady that is very useful at home. Your daddy so cherish you. He loves you so much from the depth of your heart because every time you're always checking up on daddy, you're always taking care of daddy, taking care of mommy and everybody. Everybody love you. You think as a lady, they want to now marry you. At what will happen is then you now see your parents will even cry. Your daddy will cry. You know, men don't cry. When you now see your daddy crying, he loves you. But when your daddy is dancing, he's dancing up and down. That means he cannot just wait till they should come and marry the weary out of the house. That's the meaning. Are you getting it now? The third factor is called the electron configuration of the atoms. Beautiful. So in the electron configuration of the atoms, how does it affect ionization energy? I like you to note this, that it affects in two ways. First, we have completely filled and half-filled sublevels. So these guys now is sublevels there. Whether it is completely filled or half-filled, whether your s orbital, your p orbital, your d orbital, and so on and so forth, I will explain it. How does ionization energy affect them? And number two, we'll talk about how ionization energy affects completely filled shells. Shells. You know, your noble gases, they have completely filled shells. How does ionization energy affect them? Let's start with the first, completely filled and half-filled sublevels. So if you're looking at the two of them, first, I'd like you to note this. What is the variation across the period like this, right? Beautiful. Let's say we are considering the third period in the periodic table. Sodium, magnesium, aluminium, silicon, phosphorus, sulfur, chlorine, argon. That's your third period in the periodic table. So now, don't forget this very quickly, that please, you observe something. We have established it that across the period, what will happen? Ionization energy will increase. You already know that. But please understand this, that the increase in the first ionization energy across this period is not something that is regular. It is irregular. Why is it irregular? I thought size is regular. No, it's a bit irregular. For example, if you are looking at magnesium and your phosphorus, right? They have higher than expected ionization energy. What do we mean? Follow me from here. Let me explain. Look at it. Let's say we are looking at your magnesium. Magnesium, right, is number 12. Magnesium, Mg12, right? Beautiful. The orbital configuration for magnesium is 1s2, 2s2, 2p6, 3s2, right? Count it now, 12 EB. So, sure, you see, this 3s2 that you see there, what happens? The electrons that are in the s orbital, 3s, s can hold the maximum of 2 electrons. One will spin up, the other one will spin down. What happened? The electron that you want to remove is one of the electrons there in that 3s orbital. This 3s orbital, it is 3s2. You want to remove one of the orbital there. Don't forget that that 3s orbital itself, phosphorus, right, is completely filled. Because it is completely filled, it automatically have extra stability. Are you getting it now? So to come and remove one electron from a completely filled orbital, it is very difficult. So it will even have extra ionization energy. Does it make sense? Beautiful. The same thing occurs for phosphorus. When you come to phosphorus, now phosphorus is which number in the periodic table? Hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon, sodium, magnesium, aluminium, silicon, phosphorus. So phosphorus is number 15. So it is number 15 in the periodic table. So if phosphorus is number 15, what is the orbital configuration? Very simple. Count now. This is your 1s2, your 2s2, 2p6, that's 10. Add this other 3s2, 2 plus the one that is 3 here. How many is it going to give you? 5 is all you will have there. But now, look at the 3p orbital. Because you want to remove electron, you remove it from that 3p orbital. Your p orbital, it has 3 suborbitals inside it, right? Beautiful. Beautiful. Your px, your 3px, 3py, 3pz. Now, electrons must be filled out singling before pairing will occur, right? Beautiful. And it is 3p3. So this guy like this now, that is 3p3, right? Don't forget that this p orbital, the 3p orbital, is half filled or true. If you want to come and remove one of the electron from the half filled orbital, it is extra difficult. So the electron to be removed, right, is half filled in that 3p, right? And it is now making it to be extra stable because it is half filled. There's that extra stability. To remove one electron, it will be very, very difficult. I want you not to forget this, that orbitals that have completely filled up completely filled electrons, it is difficult to remove an electron from them. Orbitals that have half-filled electrons, it is also difficult to remove an electron from them. Does it make sense? If you get this very quickly with me, the second part of it is those that have completely filled shells. A good example are the noble gases. Their shell is already completely filled. Something is completely filled. There is extra stability. To go and remove one electron from something that is completely filled, it will be very, very, very difficult. Don't forget this, that your noble gases, right? Let's say, for example, your group O elements. So these guys are called the what? The noble gases, right? Your group O elements. They have the highest ionization energy ever that you can think of. Why? We said that ionization energy increases across the period. Of course, if you are increasing across the period, you start from alkali metal, you go and land in your noble elements. So your noble gases, which are the noble elements or the inert gases, they have the highest ionization energy in any of the period you can think of. And you must note this, the noble gases have completely filled outer electron shells. Because their shell is completely filled, it will make them to be very, very stable. Because they are very, very stable, to come and remove an electron, you go here wine. Don't forget that a much higher energy will be required, right, to remove an electron from a completely filled shell. Does it make sense? Are you sure? If you get this very quickly with me, I'd like you not to forget that I gave you 3 factors that determine ionization energy. How many are the 3 of them? Number 1 of the factor is atomic size and your screening or your shielding effect by the inner electrons. Number 2 factor is called your nuclear charge, and number 3 is called electron configuration of the atoms. And electron configuration of the atom, we looked at it in 2 areas. Those that have your completely filled or partially filled suborbitals, and number 2, those that have completely filled shells, which are the inert gases or the noble gases. Does it make sense? If you get this very fast and you are sure you understand this, please and please, for the last time, what is the variation of ionization energy across a period and down a group? Don't forget this, that across a period, what happened as you are going like this, ionization energy will do what? It will increase. It increases across a period. Why? Because your noble gases will automatically have the highest ionization energy. What about down the group? As you are coming down the group, right, number of shell is increasing. Down the group, ionization energy will do what? Decrease. I like you never to forget that. As you are coming down the group, you are going to be experiencing a strong decrease in ionization energy. Across the period, ionization energy increases. Down the group from top to bottom, ionization energy will do what? It will decrease. Does it make sense? If you get that very fast, So let's rock past questions together. Let's go, guys. If you fail any of the questions, I go nod you and are serious. Let's go. Look at the powerful question that we asked here. Question 13, Jamb 1998, question 10. The question says, which of the following electron configurations indicates an atom with the highest ionization energy? Don't forget, ionization energy increases across the period and decreases how? Down the group, right? Beautiful. Which one will indicate the highest ionization energy? Option A, we're given this. Option B, we're given this. Option C, we're given this. Option D, we're given this. Does it make sense? You can say that this guy is in group 7, right? Beautiful. But this guy in group 7, it is in period 3 of group 7. This guy is in period 4 of group 7, right? Beautiful. This guy is in group 1. This guy is in what? Group 2. Let's draw the periodic table and then see something with our 2 eyes. Hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon, sodium, magnesium, aluminium, silicon, phosphorus, sulfur, chlorine, argon, potassium, calcium. Very simple. Now look at it. This guy 2,8,7, right? It is in where? It is 2,8, right, 7. It's nothing but chlorine. So that first guy there is chlorine. What about 2,8,7? You know you have fluorine, chlorine, bromine. Bromine is the one that is 2,8,7. So let's just put the last guy there. That's option D. Is the one that is what? Bromine. You already know that. Which one is now 2,8,1? 2,8,8,1. That's 9. And that's how many are you going to have there? That's 10. That's 19. That's your what? Your potassium. Potassium is 19, 2,8,8,1. And this other guy here, 2,8,8,2 is your what? Your calcium. Very simple. That's all. So you see that we have brought out the whole 4 things there. We said that ionization energy increases across the period. So as you are going like this, ionization energy is going to be increasing, but it decreases down the group. The question says, which of the following electron configuration indicate an atom with the highest ionization energy? Which one we have the highest ionization energy? Ionization energy that will be highest first. The lowest of them all is bromine, is the least. It will decrease down the group. After bromine, it will be followed by what? Potassium is number 2. It will have the next. Because you know that ionization energy will increase what? Across the period. This is the one that we now have the next. The overall highest will be for what? Chlorine. Show you this here now. So chlorine is 2,8,7. That's the answer. Which of them we have the highest ionization energy? It is 2,8,7. Option what? A is the correct answer. Get out your out of there. Very simple, easy and direct. Show you see. Beautiful. Answer this question for us. Jan 1999 question 10. The question all the way says, in order to remove an electron from 3s orbital of a gaseous sodium atom, about 496 kilojoules per mole of energy is required. That energy that is required to remove an electron from sodium, what do we call that energy? Now, this is it here. This here is your sodium, Na, right? They say in the gaseous atom of it. You now need an energy to remove an electron from that sodium. Of course, if you remove it, it's going to be what? Na plus your electron minus, right? You want to remove an electron. What is that energy that you need to remove that electron? That's what they're asking you. Option A says it is called electron affinity. Option B says it is called ionization energy. Option C says it is called activation energy. Option D says no, it is electronegativity. What is the answer? Ionization energy. Option B is the answer. Why? It is the energy required to remove an electron from a neutral atom or an ion, right, and convert it into a positively charged gaseous ion. What do you call that energy? It is called your what? Ionization energy. Option what? P become the correct answer. Look at this question that was asked. Jamb 2024, question 12. The question says, what happens to the ionization energy of elements as you move down a group in the periodic table? Across the period, ionization energy increases, but down the group, ionization energy will decrease. So this guy will increase, this guy will do what? Decrease. The question is, what happened to ionization energy as you move down? It will do what? Decrease. Option A says increase. Option B says it will decrease. Option C says it will remain the same. Option D says it will increase then decrease. Haha. What is the answer? It decreases. Option B is the correct answer. Does it make sense? Jamb 2024 as well. They brought this powerful question. The question says, which of the following metals will lose an electron least readily? The one that is not even ready to lose. If P, Q, R, and S are in the same period, but now they are in period 3, your period 4, your period 5, your period 6. Now, this guy here, your P, your Q, your R, your S, they are in different periods. But this guy is in your period 3. This guy is in your period 4. This guy is in your period 5. This guy is in your what? Your period 6. As you are coming down the group, you know you are now moving from period 1, period 2, period 3, period 4. As you are coming down the group, what happened to ionization energy? Ionization energy decreases. Sir Peter, talk to me. Which of the following metals will lose an electron less readily? The one that is not ready to lose at all. The one that will lose easily is your S, right? Because ionization energy increases down the group. Because down the group, what happened? Number of shell increases. As the number of shell is increasing, right? What happened is that the electrons in the valence shell, they are held loosely, so they can easily lose. They say which of them will lose an electron less readily? The one that is not ready to lose. Of course, the one that's not ready to lose is the one that we hold it stronger. That's the one that we have the highest ionization energy, and that is from P. That means P, which is still there, is the correct answer. Option A says P. Option B says Q. Option C says R. Option D says S. What is the answer? Option A, P, is the correct answer. Shade is here. Very simple. Sir Peter, wire me this question. WAEC 2012 question 9. The question says, which of the following correctly defines the first ionization energy? Option A says it is the energy required to add an electron. That's wrong. It is energy to remove an electron, not to add an electron. Option B says it is the energy required to remove one electron from a neutral atom in the gaseous state. Correct, sir. You are doing well. Option B says it is the energy required to remove an electron from a singly charged ion. No, that is second ionization energy. Energy required to remove an electron from a singly charged ion. That's second. Option C says it is the energy released when an electron is added to a neutral atom in the gaseous state. It is the energy released. No, it is the energy required to remove an electron from the neutral atom in the gaseous state. Option B is the correct answer. Simple. Oh, wire me this question. WAEC 2018 question 6. They brought this powerful question that says, why is second ionization energy of sodium, right, much higher than the first ionization energy? Now follow me very fast. You know, in the first ionization energy of your sodium, it's going to give you Na plus. Abi, beautiful. And sodium is 11. How many protons do we have in sodium? Sodium has 11 protons. How many electrons are here? 10 electrons are here. But when you now come down to your Na2 plus, what happened here? Here is 11. Proton here is now 11. Electron here is now even, if you watch, if for it to even be Na plus, right? It means when it loses an electron, it will fall from Na, sodium, and it will move from group 1 and go and fall into group 8 or your group O element. It will attain extra stability there. It is now extra stable. You now want to come and remove another electron. So the electrons will now be 9 here. You need greater energy. They say, why is the second ionization energy of sodium much higher than the first ionization energy? Option A says sodium becomes negatively charged after the first ionization energy. It is not true. It will become positively charged. Option B says the second electron is removed from the same valence shell. It's not true. The second electron will rather, it is the first electron that you remove from the same valence shell, from that first shell, and from the outermost shell. After that, you fall down to the next shell, right? Beautiful. Option C says the second electron is removed from a fully filled inner shell. That's very, very correct. Your sodium, right? Na plus, like this, you have it. You want to come and remove another electron, meaning you go and be removing the electron from a fully filled inner shell. Option B says the nuclear charge decreases after the first electron is removed. My dear, what is the answer? Option C is the correct answer. Second electron is removed from a fully filled what? Inner shell is the correct answer. Look at this question that was asked. WAEC 2009 question 16. The question of the way says, what is the general trend for successive ionization energy? Your first ionization energy, second and third in an atom. What's the general trend? I gave you, beautiful. I told you that your third ionization energy, right? Beautiful, is greater than your what? Your second ionization energy. It is greater than your what? Your first what? Ionization energy. In other words, let's check whether this is there. Option A, less than. Option B, greater than. This is not the answer. It is third that is greater than second, greater than first. Option C is not the answer. Option D, it is still not the answer. Now, which one is best? The answer for us there. Look at it very quickly. We said that third ionization energy is greater than second, greater than first. It means that we can boldly say that your first ionization energy will be less than your second, right? Will be less than your what? Your second ionization energy, less than your what? Your third ionization what? Energy. This is the correct answer. So which one depicts the one that is what? Less than. Option what? A. Become our correct answer and you're out of there. So it is first ionization energy is less than second, less than third, or third ionization energy is greater than second, greater than what? First. Does it make sense? Answer me this question 20, which is the last question here. Jamb 2019 question 21. They brought this sweet question all the way that says, what factor or which factor does not affect ionization energy? Which one will not affect it? Option A says atomic radius. Atomic radius affects ionization energy very well. Option B says nuclear charge. Nuclear charge will affect. Nuclear charge will very, very well affect ionization energy. Option C says your electron shielding. That's your shielding or your screening effect. It will affect ionization energy. Electron configuration will also affect ionization energy. Option D says number of neutrons. No, number of neutrons will not affect. Option what? D become the correct answer. If you get this and you are very, very sure. Now I gave you 3 factors that affect ionization energy. Beautiful. If you get this and you are very, very sure you understand this to the core, my dear, get out. You too much. Please, I beg you. I'll see you in the next class where we're going to be looking at everything about your electron affinity. You see that this class is very, very rich, right? Beautiful. Please, for the now, go to my notes. Go and finish everything about ionization energy. The questions are there. There are plenty. Go and answer all of them. Beautiful. After that, please practice CBT and always tell a friend about the Learn Lift app. I'll see you in the next class, which is all about electron watt affinity. For the now, peace out. Bye. See you there.
Hope you've enjoyed this class. Guess what? To follow up for more classes, just download the Learn Lift app, whether on Play Store or App Store, and then follow up your classes. You must do extremely well. I'll see you in class. Bye-bye.